Hello everyone, welcome to this session on artificial intelligence. In this session, we will be covering the basics of artificial intelligence so that you come to know as to what AI is, what all is there in AI, what domains are there, and how AI has progressed over all these years. So, this session will help you to understand the basics of AI. So the agenda which we have is how the AI revolution come into picture and what was the journey in last 75 years for AI, who were the pioneers and visionaries who shaped the AI and brought it to a level where it is today, what investments are happening in AI across the world, and what role data plays, how important role data plays in AI, that we will try to understand. And then we will talk about what various domains are there in AI and explain each one of them, and what is the AI life cycle, so how it is different from the normal programming life cycle. Then we will discuss on various business cases where AI plays a key role in transforming the business landscape. We'll also talk about the GPU craze, what GPU is and why it is in so demand currently. We will also touch upon the ethical part of AI and the guardrails which needs to be implemented to ensure that AI is sustainable and reliable for everyone. Then we will explore some AI tools and also discuss some surprising facts and what recently is happening in the news. So you get an overall idea of what AI is. Yeah, so the AI revolution is already here. Every day, whatever we are doing, it is being touched upon by AI. So when we go to Amazon app and we search some using some photo, so that photo search is powered by AI. You go to Netflix and you get some recommendations based on what you have watched before, so that is powered by AI. Similarly, you go to Amazon and you try to buy something and it gives you similar recommendations. So that is where AI is in the picture. So AI is already there, it is touching our lives, it has become an integral part of our lives without us noticing the same. So today we will explore that the whole journey of AI. So what are the early foundations? Okay. So it started as early as 1943, where the first mathematical neural model was developed. So it was an artificial brain, basically model, a neuron, in which there was an input, then there was an activation layer, and then there was an output. So with this concept, the thought process for AI started, and in 1950 there was a Turing test done by Alan Turing, which actually got a lot of attention from people and the whole world. So what was done was, excuse me, there were a machine and a human at one end, and then there was a human on the other end, and the human will ask questions to both of them, the machine as well as the human. It will not know which one is the machine and which one is the human. So basically, by asking questions, it should be able to find out based on responses that who is human, who is machine. And actually, they were not able to find out. And that is where more proof came into picture that AI is a separate field altogether, and there are a lot of scope over there, a lot of things can be done. And in 1956, the official term of artificial intelligence was coined at Dartmouth conference by John McCarthy, and it marked the formal beginning of the field. When we talk about 1960s and 1970s, so AI was very much limited to the basic programming, if then else programming, and there was no way by which it could replicate the real world complexity. because the algorithms were not so developed, data was not easily available, and there were a lot of reasons which we will explore as we go ahead. So 1970 to 1990 are called as the dark ages of AI, where not much progress happened. People believed in AI, but due to multiple reasons, the progress was very slow. Then in 1997, there was a major breakthrough which happened. So IBM's Deep Blue defeated world chess champion Garry Kasparov, demonstrating the capabilities of AI. And that is where the more and more attention started in the AI field, and a lot of government investment started happening. And 2012, there was a major breakthrough. Deep learning algorithm was developed by Geoffrey Hinton, and it revolutionized the whole AI landscape. It changed the way things were done in the AI landscape. It made it very fast compared to what was being done before. Then came the GAN, Generative Adversarial Network, which helped to create new content. It was a game changer as it helped to create new content. Before that, what was happening was that we were just working on the existing content. But this model helped to create new images, new videos. And then that is how all the fake videos came into picture. And in 2016, Google's AlphaGo defeated world champion Lee Sedol in a game of Go. So all this led to the popularity of AI step by step. And then when generative AI came, it took everything as a storm and it took the center stage. 2020 GPT-3 was launched, and in 2022 the ChatGPT revolution had spread across the world. It reached 100 million users in just 2 months. This is the record which has not been broken and will never be broken. And now as we see, it is a multimodal era where we are using multiple input output streams for the generating AI. So not only text but even images, videos are being given as the input, and work is being done on that. So this is how the journey of AI has been. Now why it struggled initially? So because there was limited computing power. The computing power had not reached to a level where it can execute the algorithms, complex algorithms which AI has to offer. Again, the data was not easily available, not sufficient enough. But with the cloud computing, everything coming into picture, data started easily available in the cloud. And with the internet, the data was easily available on the internet landscape. So as the data started getting more and more available, the AI started taking more and more prominence. At initial levels, there were algorithmic limitations, which were then it went away as more and more research started happening, more hardware power came into picture. So with all these things, these were the basic limitations why for 30-40 years AI did not catch up speed. But now as we have overcome all these limitations, so now AI is able to take the center stage. What is the future? The future is what AI is. So we are moving towards AGI, which is artificial general intelligence. It is transitioning from narrow AI towards AGI. So AGI is like human level reasoning. When we have AGI, it will be like human. It will be able to understand like human, think like human, reason like human. It will have emotions. So a lot of companies are working on bringing out AGI into the market, and we are very curious to see what revolution it will bring. Then we have multimodal input. We have responsible AI coming up as a separate field. So there's a lot of emphasis on you have to explain how AI has taken decisions. There should be fairness in the decisions taken by AI, and there should be strong governance and ethical frameworks to ensure safe deployment which does not harm any community or any individual. Then personalized AI is going to be the next big thing. So you will have AI which will be personalized according to your needs, according to your likes and dislikes, according to your preferences. So everyone will have their own AI co-worker who will understand their preferences, what they like to eat, what they like to read, what are their choices, what they don't like. And this AI co-worker will help to personalize everything for an individual. Again, robotics integration is a big thing coming in. So there are so many companies already going with the robotic way. In China, a lot of robots are being used to do manufacturing, to deliver the food to people once they order from the hotel. So these things are going to increase with time, and each of us will have robots at home. Again, the warfare systems, AI has a very big role to play over there. So we saw in the recent wars, a lot of AI was used, drones were used. So a lot of research is happening in the warfare area. Now we come to the pioneers of AI. Who were the people who actually led to this revolution? Who were the people who helped us to come at a stage where we are? So Geoffrey Hinton is known as the father of deep learning. He was the one who found the deep learning algorithm which changed everything. So deep learning algorithm actually mimicked the human brain in computer. It gave computer the power of a human brain, and through it, lot of revolutions started happening. Then came the transformer revolution. It was developed by two Indians, Ashish Vaswani and Nikki Parmar. So transformer was one step ahead in deep learning, where it was able to give attention to the content. It was able to give multi-head attention. So instead of learning each sentence, it could understand the whole paragraph at once. So it was a major transformation which happened, which led to the generative AI systems and whatever development which we are seeing currently. So deep learning and transformer models are the key behind that. And then Mira Murati from OpenAI, she developed ChatGPT and brought it to everyone's desk. It was like a democratizing AI, where AI was felt by each and every individual residing on earth. It was a major breakthrough. So these people have shaped the revolution through their technical expertise. Now we will also see who are the visionaries of AI, who have invested in AI and who has a vision of how AI will move ahead. So Sundar Pichai is at the center stage. His company Google is using AI since 2016, and he has also developed Google Tensor Processing Unit, which is going to revolutionize the AI infrastructure. Then we have Jensen Huang, CEO and founder of NVIDIA, who is the actual hardware brain behind what AI we are using today. So the GPUs are manufactured by NVIDIA, and GPUs help in running the algorithms at a very fast pace. Sam Altman, another visionary who has brought ChatGPT to our desk, to our as a co-worker, and now everyone is able to utilize the power of ChatGPT free. And this is what has led to the democracy of AI. This is what has led to the adoption of AI across the world. So with all these visionaries and pioneers, we have come to a level where we are. And now what investments are being made? Huge investments. So Microsoft $80 billion, Amazon $100 billion, then Google is $75 billion, and Meta 72. All of them are putting this money in various data centers, buying GPUs, because they know that soon the AI revolution will take off and everyone will need GPUs to run their programs. So this is where the investment is going in. And India is not left behind. India is at the center stage. So the government itself has dedicated 10,371 crores over a period of 5 years to AI, and it involves various parts like infrastructure, then applications, skilling programs, startup support, and ethics governance. TCS has pledged 6.5 to $7 billion. Google is trying to invest $16 billion in Vizag. Vizag is going to be the AI capital. And the benefits of AI, the numbers tell the story. So 20% diagnostic accuracy we get in medical diagnosis. Then fraud detection, which used to take so much time to get detected, it happens instantly. There is a 500 manifold increase in the detection of fraud. Downtime is reduced because AI systems are able to identify the issues well in advance, which was not possible by the human intervention. So all of this proactive monitoring has helped to reduction in downtime. Then there is a productivity boost because AI is able to act as a co-worker. It is able to automate workflows. There is a lot of sales improvement because the recommendation systems are doing a great job. The AI behind the recommendation systems is responsible for giving the right choices to users, and then they click on the buy button to improve the sales. A lot of cost reduction is definitely there because as AI is automating things, so we need less and less manpower, we experience less failures, and operational costs are optimized. So the bottom line, it is delivering the ROI, cost reduction, and also revenue growth. Now when it comes to AI, the base of AI is the data on which the algorithms run. So data is nothing but whatever data is collected by an organization and stored in their databases. This data is then provided to the AI algorithms, and the algorithms, they run on this data and generate the statistics and the insights which are helpful to do predictions. So the basic raw data for AI is the organization's data. So this data is very, very important. So here the chef analogy comes into picture, where data is like the ingredients and algorithms are the recipes. And your final dish will depend on both of them. So if data is not proper, then whatever algorithm you use, you will not be able to get the benefit. It's like garbage in, garbage out. Hence, data plays a significant role. There are a lot of techniques used to bring data to a level where it becomes very easy for the algorithm to predict. There is a concept of synthetic data going on. Everywhere you will hear this. It's about creating data which is not real. It is synthetic in nature. So every time you may not get real data, like for example Aadhaar cards. So if you want to do something on Aadhaar cards, you may not get Aadhaar cards from the company. So you have to create synthetic Aadhaar cards. So that is where synthetic data comes into picture. You can create it using algorithms, using various generative tools, and it's almost free of cost. You don't have to buy the data, and there is no privacy restrictions because it is all generated data. It is not belonging to anyone. So this has been the core of the AI algorithm processing, because synthetic data helps in bridging the gap. Data augmentation is all about expanding the data. So if you have 500 images samples but you want 2000, so from those 500 images you can do some manipulation and you can take it to 2000. So you can do some rotation, flipping, cropping, you can add some noise, or you can do some color adjustment, and then you get more images. So this is data augmentation. So most important thing, data should be accurate, it should be consistent, same format and unit should be used across. There should not be any bias. So the data should be fair. It should not have data of only one community or only one gender. It should be across equally, and it should be complete. Missing values should not be there. So AI is not a monolithic system. It is a combination of so many modules, right? So it started with machine learning, then it went to deep learning, natural language processing, computer vision, agentic AI, generative AI, RPA. So all this whole concept is to help the computer develop the exact similar senses which humans have, right? So computer vision helps the computer to see. It is the eyes of the computer. Similarly, NLP helps computers to talk and understand human language. Similarly, we have deep learning, which is the brain, which mimics the brain of the human in computer. Generative AI is about generating new content. Robotic process automation is about doing the tasks which are manual in nature automatically. And agentic AI combines all of these together to create agents like humans who can think autonomously, who can do things on their own. So we will quickly go through each one of them. Machine learning. Machine learning is a machine, it tries to learn based on the data which is fed into the algorithm. So machine learning is all about learning the patterns. It is about learning from the data, how the data is, and then based on that patterns creating a map of its own so that it can do predictions based on that particular map. So some examples are email spam filtering. So whether the email is spam or not spam is an example of machine learning. Giving you recommendations, then predicting if user will default in his loan, diagnosing the diseases using patient's data. So all these are machine learning examples. And again, machine learning itself consists of various subsections. So there is a supervised learning, there is an unsupervised learning, reinforcement learning, semi-supervised learning, incremental learning, etc. So there will be a separate video on machine learning where we will be covering all of these in detail. Then we have computer vision. So it helps machines to see. So basically it empowers machines to interpret, analyze and extract meaningful insights from visual data like images and videos, right? So the computer is able to recognize the face. It is able to drive the vehicle automatically by seeing its surroundings. It is able to understand its surroundings and take decisions accordingly. So all these are examples of computer vision. So here what happens is that all the images and external world videos are fed into computers and they are able to derive patterns from them through which they are able to decide what actually the image is or where a particular object lies in an image. So all this comes under computer vision: object detection, then image processing, then image classification as to whether the image is a Aadhaar card or a PAN card or a bank statement. Then there is video analysis. So there is a video of a cricketer and you want to do analysis of how he has played, whether he has played properly or not. So all this comes under computer vision techniques. Then we have segmentation. Segmentation is dividing the image into multiple segments. So the head, if there is an image of a human wearing a dress, then head separate, the upper part separate and the lower part separate. These three are the segments within an image. So this is a complete field altogether and we will be discussing in detail on this as we go ahead in our next lectures. Then there comes natural language processing. It is all about helping computers to understand our language. So actually computers can understand only numbers and it operates on numbers. So this is a mechanism through which we convert our language into machine understandable form and vice versa. So there are key components involved over here. There is text processing involved where you have to clean the text before you give it to the computer. There is text classification has to be done. So you categorize it, the text, into various different segments. You try to extract information from text. You try to translate it from one language to another. These are all different use cases of natural language processing. Conversational AI chatbots are there where it is able to understand our questions and give us the answers. Then there is summarizing of long documents, processing the speech, converting it into text and vice versa. So it's a big field altogether, and NLP has actually led to generative AI. So NLP is the root from where generative AI has taken and come into picture. Then we have deep learning. Deep learning is relies on the neural network architecture where everything is considered as a neuron. There is an input, there is a neuron function which transforms the input, and then there is output. So there are multiple neurons connected, leading to simulation of a human brain, and it helps in understanding the data and the images and the patterns very clearly. So we have feed forward networks, CNN, RNN, GAN, and transformers. So CNN are mostly used for images. Then RNN are used for sequential data with feedback connections. So basically reinforcement learning. And transformers are used for text, majorly text. So all our chat GPT and all, these are all based on transformers, where it is GPT means generative pre-trained transformer. Then we have GANs, where GANs are able to generate new content. So there will be a separate section on deep learning where we will discuss this in lot much detail. Generative AI. Generative AI is a field which generates text. So ChatGPT, Claude, Gemini, Grok, Perplexity, all these are examples of generative AI. Why generative? Because they don't just understand the text, they generate new text, they generate new words based on your input. So basically how this happens is, first there is a tokenization concept where the whole sentence is broken into tokens, and then there is a embedding created, so it is converted into a vector, a numeric form, and then it tries to understand the semantic understanding based on the vector and the value of vector. There is a concept of cosine similarity which is used to understand the semantic understanding. So how the models are trained? So there is an input output pair. The model is shown huge amount of text examples. So just imagine ChatGPT generating code for you. How it is able to do that? Because it has been trained on billions and billions of lines of code. It has seen so much code. It has made its own interpretations and patterns out of that. So now when you give it something, it is able to quickly fetch it and generate it as per the context from billions of input parameters which it has. So GPT-4 was trained on 45 terabytes of text. So it learns by prediction, and then we give the feedback to it, and this repeats, and by repetition it is able to improve. So whatever we are doing with generative AI, we are helping it to improve further. And just see the scale of data. If a human reads one page per minute for 12 hours a day, it would take 20,000 years to read what ChatGPT has already seen. So there will be a separate lecture on generative AI in detail. Here we are just covering the basics. So when you type AI is transforming the way business is, then the next word prediction tries to find out the most probable word which can come. So it can be operate, function, work, or grow. And then through cosine similarity, it tries to find out the probability of each word. So operate has the highest probability because it is nearest to the contextual meaning. So it provides the next word as operate. This is how each single word is generated. Then we have agentic AI, which is currently in form. It is the most hottest topic in AI, and this is revolutionizing the whole industry. So what is agentic AI? Agentic AI is like a human who can take his autonomous decision, who can change his decision according to his surroundings, who can reason, who can do planning, who can perform actions. They have memory, and they are able to adapt to the changing environment. So basically it is a combination of AI and non-AI components which are able to work as an autonomous system. And this is where the final product of AI comes into picture, because this is what actually helps the business to operate independently without human intervention. So some examples are the self-driving cars, right? So those cars are able to perceive their environment and they are able to change their direction based on the environment. So they come under the category of agents. We have autonomous robotics. So robots in manufacturing facilities or robot delivering a food parcel to a home. So it will adjust itself according to its surroundings, depending on the traffic or whatever disturbances come in his way. It will change its course. Then we have algorithmic trading systems, where automatically that does the trading without our intervention and changes its strategy based on the market conditions. So this is, again, we will have a separate lecture on this. Then we have robotic process automation, which is just automating whatever is the manual work. So UiPath and Automation Anywhere are two very important softwares which are used over here. This is the AI life cycle. So business case will be given, then you will do data gathering. Then based on data, you will do the pre-processing, because here refinement of data is very, very important. So the more you refine the data, the more you process the data and bring it to a form where it is easily used by the model, then you get the best efficiency. So that is the main purpose over here. So data pre-processing, then exploratory data analysis. So we visualize the data, we try to understand data through various graphs, what the data is like, what needs to be done further. And then we do feature engineering. So feature engineering is the buzzword, you might have heard it so many times. So feature engineering is nothing but it consists of basically identifying those features in the data which are critical for prediction and removing those features which are not at all required for the prediction by a model. And third important part is to derive new features which will aid in better prediction. So these three parts consist of feature engineering. Then once you have done the feature engineering, your data is ready to be given to a model. You do the model selection. So there are various techniques used for model selection. We will cover them in detail in machine learning topic in that separate lecture. Then once model is selected, then we do the training of the model and see what is the efficiency. The evaluation is done. And then there are hyperparameters which are available to us for tuning. And this tuning helps in improving the efficiency. So this is a trial and error where we do multiple tuning and see how it impacts the efficiency, and then we finalize the model. Once model is finalized, we have to ensure the security and the guardrails are present. So guardrail is nothing but those validations which helps AI to perform properly. It does not go haywire and no one is able to bring it to a halt. So these are the guardrails which are basically the restrictions which are put into system. So for example, if you tell a ChatGPT to print one letter continuously 10,000 times, then it will, if it does that, it will hang the whole server over there at the cloud. So this kind of request should be prohibited. So those kind of guardrails has to be built within each system. And then you do the production deployment, and then you keep doing the ML ops, the machine learning operations, where you keep seeing what is the efficiency, you keep improving it with new data set coming in, you again run this whole cycle again. So this is the life cycle of AI. Data pre-processing. So whenever you get the data, there are so many things to do on that. For numeric data, there will be missing values which you have to handle. Then there will be outliers. So missing values you will replace by mean. Outliers are like for a salary of a company employees, the salary of CEO will be outlier because it will be two-way high than the salary of the normal average employee. So those data points has to be taken care of. They have to be removed so that the model does not get incorrect data for its processing. Then data imbalance has to be taken care of. Then for text data, you have to clean the text, tokenize it and vectorize it. Image data is there, then you have to remove the noise from the images, because images have so much noise in it apart from the actual features which are required for the model to process. We do data augmentation, bring it images to all class of images to same level. So if we have only 500 PAN cards and we have 7,000 Aadhaar cards, though we will augment the data of PAN card so that it will also come to 7,000 before we give it to the model. Then there is color transformation, feature extraction. So each mode of data has its own data pre-processing steps. Some examples are handling missing values, filling or removing null values, then encoding categorical data, converting text to numbers, because computers only understand numbers. So we have to convert it to numbers. So if there is a gender of male, female, we convert it to 1 and 0. Then normalization is very important, bringing all features to a similar scale. So if there is a age 52 and there is a salary of 65,000, then both of these are two extreme ranges. So we have to bring it on a common scale. We have to convert it to some value between 0 and 1 so that it indicates the relationship between these two values properly. Then outlier removal is there, data type conversion is there. Then comes feature engineering. So feature engineering is transforming the raw data into features that will improve the performance of the models. So either you will remove some features which are not at all useful in prediction. So for example, if you are trying to predict which customer is going to default, then the gender of the customer or the address of customer will not determine that, will not be playing a role in that. So you will remove those features before giving to the model. So that is reducing the features to minimal, which are important. Then you will derive some features. So you have some data available, you will try to create more features out of that. That will help the model to process in a better way and give better accuracy. And then the third part is that we will add some features which are more important. So removing features which are not important, deriving new features and adding new features. So this is what feature engineering is. Combining two or more features, then reducing redundant features and generating new features. Exploratory data analysis deals with analyzing the data, analyzing the quality of data, how the data is, and also the patterns which are hidden in the data. So we come to know about the patterns that helps us in finalizing which algorithms to be used for that particular project. So EDA, you try to understand the distribution of data and its structures. Then you identify missing values and outliers, anomalies, and correct them. Then you detect duplicates, remove duplicates so that the model gets clean data. Then you study various plots, histograms, and you find out the correlation between various metrics or various fields which are there in data. So you come to know that which field is dependent on which field. So all these insights from data is derived through EDA. There are various libraries available, boxplot, scatterplot. So matplotlib and Seaborn libraries helps in achieving this. So these are some examples. Understanding basic stats of data, plotting to see trends, checking the relationship between the variables, then exploring how the target varies with the predictors. Then we have model runs, and then we do hyperparameter tuning. So here we have some parameters within our reach where we can change their values in a model. So we do multiple trial error to see how it impacts the efficiency, how it improves the efficiency, or in that way we are able to fine tune and come to a better efficiency by doing trial and error. So every different algorithm has their own hyperparameters. There is learning rate, batch size, epochs, momentum. So all these parameters are used judiciously to improve the performance. Some examples are there for the algorithms. So for example, max depth is 5. You can increase it. You can increase the epoch size, learning rate, batch size, and see how you get different outputs. And then you can finalize on the best performing parameters. Now we come to the actual use of AI, where AI is being used in industry. So many use cases are there. We will cover for software from a software perspective as well as from a hardware perspective. So bank fraud detection. So detecting the fraud transactions in real time is one of the best use case of AI. So AI is able to quickly see the patterns of all the transactions and quickly identify if the pattern is different and raise an alarm. Then credit risk prediction. So you want to predict if the customer should be given a loan or not. So how much is the credit risk? So you can use AI to understand that. By there are so many data points which AI will work on, and it will come up with a probability of the person defaulting. Billing and invoice automation. You can automate the complete billing process. Customer chatbot for loan queries. So you can have a chatbot which can handle maximum traffic from the customers, so that more and more people you can reduce from the mundane task of handling customer calls. Then you can do PII masking using AI. So there are so many RBI regulations which mandate us to mask the Aadhaar number, PAN number, or PII number, personally identifiable number, in documents which are stored as images or PDF. So AI helps in identifying these Aadhaar numbers and then masking them. We can classify the documents, whether they are PAN card, Aadhaar card. So all these are very useful use cases of business. Then dynamic airline ticket pricing. So you can use the data points to find out what should be the right price for a ticket, depending on the season, depending on how many tickets are still left, depending on the customer's grade, whether he is a platinum customer or silver or golden customer, and so many other parameters. So it can be given to algorithms, and algorithm will come up with a value for that ticket which will maximize the profit and also help in getting the tickets booked by the customer. So this kind of analytics, this kind of use AI is giving to all the business, and it is transforming the whole business landscape in a very disruptive way. If we see, then cyber threat detection is there, customer EMI default prediction. We can predict cancer using AI. So AI can be used to scan the CT scan and MRI images of a patient, and then it can locate the cancerous growth with certain probability. We have e-commerce product recommendations where Amazon, Netflix, Flipkart, everyone is using AI to recommend products to customers based on their previous purchases, based on their interest, based on their budget, based on so many parameters, right? So it helps in improving the business. Then you can do factory energy optimization. So in a factory, we can study the energy patterns, and we can use AI to predict and reduce the energy consumption over a period of time. Predictive maintenance can be done. So AI can use the data points from IoT sensors to predict whether this particular device requires maintenance or it can still sustain for few more days. real-time traffic management. So in the signals, you can, depending on the queue, you can increase or decrease the green signal time, and that will help in managing this traffic signal very effectively. This can be done using AI. You can have personalized learning systems. If customer is going to leave or not, you can predict that. Then in infrastructure also we have multiple cases. So you can do network anomaly detection. If there is any traffic which is anomalous, then it can easily be flagged by AI models. In security, you can do threat detection on immediate basis. Intelligent storage management can be done, where depending on the logs, it is able to identify which storage is going to fail and when storage is going to get full. So early alerts can be generated to take corrective action in backup, OS, data center. So the use case are enormous. Some success stories in India. So TB screening was done by Municipal Corporation of Greater Mumbai, and 1 lakh plus people screening time was reduced to 30 minutes using AI X-ray analysis. Yield prediction was done in Haryana using satellite imagery, soil data and weather patterns. Crop disease detection was done in Tamil Nadu. Then 85% of grievances were handled through AI system, which resulted in reduced resolution time for the customer as well as reduced manual intervention. Andhra Pradesh used it for virtual learning to deliver personalized learning to 4 million plus students. So the success stories in India are rising. People are moving ahead with AI based business solutions. Rural water monitoring is there, telecom security, Param Siddhi AI. So these are just the government initiatives. There are a lot of businesses which are successfully using AI. SDFC chatbot EVA is one of such example. Now there is a lot of need for guardrails and security in AI because it can go wrong sometime. So the key lessons which we have learned from history. So in Amazon, they created a recruiting tool, and that recruiting tool was trained on data which was majorly for male CVs. So what used to happen is that it used to reject the female candidate because the gender on what it was trained was only male gender. So that came to light and then gave the correct idea as to how data is important, and any bias in data will lead to wrong predictions. Then Taco Bell had a issue recently where someone ordered 18,000 cups of water and the whole system failed. So there was no guardrail present which could prevent such failure. So all these things needs to be taken care of. Deloitte's AI report was incorrect. It was produced by using generative AI, and it was not reviewed by human and given it to the Australian government. That led to heavy fines. IBM's Watson Health did 4 billion plus investment without any actual benefit coming out of the same. So a word of caution is there where we have to be careful while using AI. And how GPUs help. So GPU are graphic processing unit. They have very high processing power, and these algorithms of AI and the used data, they need high processing power to execute and get completed in reasonable amount of time. So if you use a CPU to run a program with used data, it may take 18 to 20 hours for one run. And if you replace the CPU with a GPU, top level GPU, it will get executed in 1 hour. So you will save so much time, and also a guarantee that it will get executed because your CPU might fail in between due to overload. So that's why GPUs have taken center stage. Everyone who is using AI models, running AI algorithms, they need GPU. Without GPU, they cannot run. And hence the companies who are giving GPUs on rental basis, on hourly basis, they are striving. Nvidia reached $4 trillion because of this simple fact that AI uses GPU. So there are various GPU models ranges from 15K to 28 lakh INR, and the power ranges accordingly. Then we come to sensitive topic of ethical principles of AI. So it is, though we are building AI, we are integrating AI, but this principle needs to be taken care of. The responsible AI is that it depends on ethical aspects. It has to be fair, transparent, and accountable, and it has to be explainable. So explainable AI means that whatever decision AI has taken, there should be reasonable data saved in the database which can explain the decision whenever an audit query comes. Similarly, you have to secure it. You have to protect AI systems from cyber attacks, adversarial inputs, and data leaks. It should be fair. AI should be fair. It should not give biased decisions like rejecting female CVs or rejecting female candidate or rejecting someone from a particular community. So bias should not be there. It should be fair. And it should be trustworthy. It should lead to people's trust. People should have trust in the decisions taken by AI. If people don't have trust, then the business will not be able to survive with AI solutions. And it should be sustainable. So when AI runs on GPU, a lot of processing power, electricity is used. So definitely we have to come up with renewable sources which are actually help to address this significant rise in the usage. So it has to be sustainable. Some critical guardrails for AI are security protection, privacy compliance. So privacy compliance means that any information which is personally identifiable, it has to be masked before you send it out. And you have to adhere to the local policies like DPDP Act, which has recently been approved. Then bias prevention is that it should not be biased against some particular community or societal inequality. And accountability means it should take complete accountability. We cannot tell that AI has done a mistake, so I am not responsible. So the accountability lies with the company who implements AI. Then there are some AI jargons. So edge AI refers to the AI on which runs on a mobile. Physical AI is actually the robotic part. Digital twin is actual twin of a production system which can be used for experimentation. Then we have so many other jargons to learn. AI toolkit is there. So ChatGPT, Perplexity, all this helps in daily productivity. Copilot helps in automation and workflow. Notebook LM is one tool which helps in document summarization. Analytics and visualization, you can have Gamma for presentation building. Low code, no code platforms, Lovable, Jotform. AI versus non AI. So this is very simple. We are able to understand where AI takes a role and where non AI takes a role. So like email categorization. So if you do rule based, then it is non AI. If you do NLP based, it is AI. Customer support, fraud detection. So all these can be done using AI as well as using non AI. When you use AI, the learning ability comes into picture. You are able to handle uncertainty. Input types are taken care of, and decision making happens based on algorithms. Some surprising facts. So AI consumes 2% of world's electricity currently, and it is going to increase to 6% by 2030. So electricity is going to become very costly. It can translate between 100 plus languages. 83% enterprise rank AI as a core business strategy. AI is able to discover antibiotics which would take humans centuries. There was a painting created by AI which was sold for $432,000. Demand has rise by 14 times for AI roles, and it is able to solve complex human biological challenges. Also, it is able to transmit signals from brain to computers using Neuralink. Some of the news of AI. The Google is going to invest $16 billion in Vizag. Vizag is going to be the AI capital. Deloitte published a report which was incorrect and had to repay the contractual amount back. Future Life Initiative is an organization in US which is now trying to stop the growth of AI, as they are seeing a lot of issues as AI advances. There was a prank order in Taco Bell which led to shutdown of 500 locations in US. As per recent draft proposal, in India you have to explicitly mention if you have generated content through AI. This rule is coming in, and once it comes in, all AI generated content will have to be explicitly marked. Yeah, so this is all about the basics of AI. I hope you will go through the whole video at your own convenience, and you will like the video and like the content which I have shown over here. It will help you to increase your AI quotient. Thank you so much.